There's antimony, arsenic, aluminum, selenium, and hydrogen.
Hey scientists, today we're going to be doing one of my favorite labs, and that is the Copper Cycle Lab. So in the Copper Cycle Lab, we're exploring one of the fundamental principles of chemistry, and that is that things change, right? So we're taking ordinary copper, the same kind of copper that you'd find on a penny, but in this case we have ground up copper dust here. We're taking that ordinary copper and we're going to be leading it through all sorts of cycles and changes. We're going to see it change colors. We're going to see it change forms from a solid to what we call an aqueous, which is a liquid. Okay? So we're going to be looking at all these cycles, all these changes, but the whole time we're going to be thinking, where is the copper? Okay, so for our first step here, I'm going to be measuring out the copper that I'm going to be using for the rest of the lab. So for this first step, I'm going to take my beaker, put it on my scale, and then I'm going to hit 0. And what that does is it makes it so that my container is at 0, and whatever copper I add now is actually what I'm weighing out. Our lab instructions say to use 0.1 grams of copper. For our purposes, we're going to use a little bit more than that so that we can show you the reaction really clearly. So I'm going to weigh it out and go for about 0.5 grams. 0.52 is perfect. So the initial mass of my copper is going to be 0.53 grams. So for this next step, we're going to be adding nitric acid to the copper, and we're going to again look for the change that occurs to the copper, make very careful observations about what is going on, what is being produced, and thinking about where the copper is. Okay. So because we're using nitric acid, which is a strong acid, I need to protect myself properly. So I have my apron on now, and I'm going to put on these nitrile gloves which protect my hands from that acid. Anytime you're working with a strong acid, you either want to be very careful or make sure that your instructor is helping you out by doing that step for you. Okay, so now I have my nitric acid in my bottle here. This is my 8 molar HNO3 nitric acid. I'm going to take this and pour it into a smaller container so it's easier to draw from it, and also so I don't put anything back into the stock container. I'm going to reseal that. Okay. To make sure that I'm getting the right amount of nitric acid and administering it carefully, I'm going to use what we have here that's called a pipette. And so this pipette actually allows me to draw up a very specific amount of milliliters. See on the tube here, it's marked with different numbers of milliliters. And I'm going to draw out, our lab says about 2 milliliters. We're going to go a little bit more than that since we have a little bit more copper. So I'm going to draw that out with the pipette. Okay, so now I have my nitric acid. I'm going to take it, I'm going to add it to the copper. I want you to watch very carefully to see what happens to the copper. You should be able to see a change occurring. Make specific observations. What is happening in the beaker? What is happening above the solution in the beaker that I just added? And as I swirl it, what happens? Make observations as to color, as to state of matter. Were there bubbles? Did you hear a noise? Anything like that. The more specific you can be with your observations, the better. Okay, give it one final swirl. And continue writing down observations. Continue telling me what you see. Okay, now for this next step, for step 3, all we're going to be doing is taking some water, about 25 milliliters, in this case about 50 milliliters, and adding it to our beaker. So make sure to observe the change carefully and tell me what happens when I add that water to this beaker. Make careful, specific, detailed observations. What changes? The color change, state of matter change.
For our next step, we're going to add a strong base, 8 molar sodium hydroxide. I don't want to contaminate the stock bottle. So like we did in a previous step, I'm going to distribute some of this into a separate beaker and then close the stock bottle and set it off to the side. We're using the glass serological pipette again. Your lab procedure asks you to distribute 2 milliliters of the sodium hydroxide. Because we want the appearance to be quite obvious, I am actually going to put in some more. When you see this base enter the copper solution, there will be many subsequent changes, so you will need to continue to make observations. Pay attention to not only color, but any textures or shapes that you note. It's sometimes helpful to use analogies for objects or processes that this reminds you of. For our next step, we're going to transfer the solution onto the center of ceramic hot plates. These hot plates are great because they not only heat the solution, but you can additionally add a stir bar to them. A stir bar is a little magnet. When you slide it into the beaker and then you turn on this wheel, it's going to stir it for us. Oh. I'm going to turn on the heat. I'm going to crank this puppy up. Let's say we're going to do 400 degrees Celsius. I'm most likely not going to let it get that hot, but I kind of want to speed this up a bit. And then turn the stir bar on the left solution. You'll notice that we're doing this lab in duplicate. It's nice to have duplicates in science. And because this step takes a little bit of time, we will time lapse and make sure to show you from various angles. As you watch, record any observations regarding color, texture, anything else you think is important. Now that our glassware has cooled down, we want to separate the liquid from the solid that collected in the beaker. We call the solids that separate out a precipitate. Kind of think of like precipitation, like falling down from the sky or like falling out of a solution. It's possible that the beaker might just be a little bit warm still, so whenever I touch it, I still am going to put on the hot hands out of an abundance of caution. Our filtration apparatus, I love that word, apparatus. We've got our ring stand with an adjustable iron ring attached, a plastic funnel set inside, and then a beaker below to collect any liquid that comes through. Right now, the funnel just has a hole at the bottom. We are going to use filter paper. It's kind of like a coffee ground filter. Take one of these circles, fold it gently in half, pressing the crease very softly, and then fold it in half again. I'm not using my fingernails because I don't want to tear the paper. If I grab just one edge and separate it from the other three, I have a little paper cone that's super cute. When I stick it into the plastic funnel, it's probably going to pop back out. And because this can move around, I will dampen it with a little bit of distilled water just squirted onto the sides to make sure that it sticks. I'm adding my hot hands, very fashionable, grabbing my mixture, and then slowly pouring it into the top of the filter. I want to pour slowly so that I don't pour out of the top. Note the liquid that is coming through the bottom. Compare that to what it looks like in the funnel. There is still some residue stuck on the edges of this beaker. I can capture that by giving a little rinse with some more water. We want to try to get all of that precipitate that we made. But it won't be perfect, and if some sticks to the glass, that's quite all right. Our liquid has dripped through the filter paper. We want to gather the residue that collected inside of the funnel. I'm just using a little metal micro spatula. I'm gently scraping that residue off and then putting it into a clean small beaker. Because you're not going to be able to really see this up close, it has sort of a melted chocolate syrup texture. And because it's not easily falling off the spatula, I'm just continuing to scrape the residue in the same place so that I'm not making the entire beaker dirty.
Okay, so now for our next step here, we have our solid copper mud over here. It's got that rich brown color to it. We've collected all that, filtered it out, and so now we're going to be adding sulfuric acid to that. So we're going to add this sulfuric acid, and again, look for very specific observations. Look for what change is taking place here, how the color is changing, how the consistency and the texture is changing. So we're going to go ahead and add our sulfuric acid and look for that change. So now for our next step, we've measured out a little bit of zinc filings. So I'll go ahead and show you those. Got our zinc filings here. They just look like shiny silvery metal bits. We're going to add those zinc filings into the beaker and again observe what happens. Make careful observations as to what you see changing. So you should start to see some changes obviously going on in the beaker. Keep watching to see what happens in terms of colors changing, what states of matter you might observe. Be very specific and detailed in your observation. And again, remember what we were thinking throughout this whole lab, where is the copper? Okay, and for our last step here, we're going to take our solution with our new solid in the bottom. You should be able to see that solid pretty well. Okay. We're going to pour that off, making sure to keep all the solid in there that we can. This is a technique we call decanting, where you pour off the liquid from the solid and keep the solid at the bottom. All right. Okay. So now you can see we have most of our solid left in there, all the liquid's gone. Think to yourself, what happened to the copper? Where did it go? Make careful observations here about the solid that's left remaining. And how does it compare to what we put into our beaker at the very beginning of our experiment?